Hey guys, today we're going to be learning about limiting and excess reactants. And so in the real world, reactants aren't represented by like an exact mole ratio as described by a balanced equation. So nothing, we don't really do things in perfect moles. This means that one reactant will be used up before the other. So the reactant that's used up first is called your limiting reactant. And that's what's going to stop the reaction. Once you run out of one of the reactants, the reaction can't go on anymore. And then you have your excess reactants, which are the reactants that remain after the reaction stops. So an example, if you put one drop on an Alka-Seltzer tablet, what would be your limiting reactant? So let's think. We have this big Alka-Seltzer tablet and only one drop of water. The water is going to be our limiting reactant. And then our excess would be the Alka-Seltzer. And then it says, how could we switch the roles of these two? So this would be like when we put one Alka-Seltzer tablet in a huge bottle or a huge cup of water. And that's how we would switch them. So just as a review, limiting reactant is the the reactant that's used up first and stops the reaction. And excess is what remains after the reaction stops. Hi guys. So we're gonna start with our first practice problem. So assuming we started, so let's read. This is our balanced equation, and let's read our equation. So, assuming we started with 30 grams of ammonium nitrate and 50 grams of sodium phosphate, how much? How much is? So it should say how many moles of sodium nitrate is produced. That's a typo. Sorry, guys. So the first thing we're going to do is whenever you are doing a limiting and excess problem, you're going to have grams or the mass or whatever, it could be grams, particles, whatever, of both of your reactants. So in this case, we have 30 grams of ammonium nitrate, and then we have 50 grams of sodium phosphate. And then it's asking how many moles of sodium nitrate are produced. So whenever you're doing these, you're going to need to do two stoichiometry problems. Two stoichiometry problems, that's a lot of problems. I know, you'll be fine. So we're going to get started, and we're going to start with 30 grams of ammonium nitrate. So I've already drawn my T-chart, and I've already put my 30 grams of ammonium nitrate here. So we are going to have to go, for this stoichiometry problem, we are going to go from ammonium nitrate to sodium nitrate because the question is asking how many moles. So we're going to go from ammonium nitrate to sodium nitrate. But in order to do that, we're starting with grams of ammonium nitrate. So whenever we're going from grams of ammonium nitrate to something else, you need to go to moles first, because whenever you're doing the switch, which is right here, and it's not written, so I'm going to write that right here. Whenever you're switching from one compound to another or one substance to another, you're going to do that through moles. So the first thing we're going to do with this problem is we're going to convert our ammonium nitrate to moles. And whenever you're doing that, we're going to be going from grams to moles. We need to look up the mass on the periodic table. And I've already calculated that for us. And that calculation is right here. Okay, so we have N, we have one N, actually we have two N's, I separated them. And so it equals 14. Then we have NH4. And so we have, and the mass of hydrogen is 1, nitrogen has a mass of 14, and oxygen has a mass of 16. So I multiplied all of these and then I added them together and we got 80 grams equals 1 mole. So first thing we're going to do is we're going to take down our units. And so we're going to have grams of NH4NO3. And then on the top, we want to convert this to moles of NH4NO3. And so like we have right here, we have, 80 grams of NH3 of NH4NO3 equals 1 mole. Okay, so now we are at moles of NH3. And now we can do the switch. So in our next equation, we're going to take our moles of ammonium nitrate and we're going to bring that down. We have moles of ammonium nitrate. And we are going to do the switch to sodium nitrate. So we're going to do moles of sodium nitrate. Sodium nitrate. And so we're going to look up at our problem and we're like, okay, how many ammonium nitrates do I have? I have 3 of them. So I'm going to put a 3 right here. And now I'm going to look at my, okay, how many moles of sodium nitrate do I have? Okay, I have 3 of them. So I'm going to put 3 here. Okay. Our question is asking for moles of sodium nitrate. And so we have moles of sodium nitrate. So I'm going to go to my calculator. I'm going to go to my calculator and we're going to multiply everything on the top and divide by everything on the bottom. So we're going to go here, we're going to do 30.0 times 1 times 3, enter, and then we're going to divide by everything on the bottom. So divided by 80 and then divided by 3. And so our answer is we have 0.375 moles of N of sodium nitrate. Okay, now we're going to move on to our second equation. Our second equation, we are going to use our grams of our other reactant, which is sodium phosphate. So same thing, I'm going to draw my T-chart and I'm going to write 50 grams of sodium phosphate is where we're starting. And just like the one above, we're starting with grams. So whenever we have grams, we're going to have to find, whenever we have grams, we're going to have to convert it to moles. Because in order to do a switch from one element to another or one compound to another, you need to convert everything to moles. So how we're going to do that is we need the molar mass. And same thing, I've done the math. The molar mass of sodium phosphate is 164 grams. So we're going to take our grams here. We're going to take our units. We're going to bring it down. We have grams of sodium phosphate. And then we have moles of sodium phosphate at the top. And then we're going to come here and we're going to have 164 grams of sodium phosphate equals 1 mole. Okay, and now we have moles of sodium phosphate. And now we can switch to our last thing we want to do, which is we want to get to sodium nitrate. So we're going to take our units, we're going to bring them down. And so we have moles of sodium phosphate. And now we want to go to moles of sodium nitrate. So now whenever we're doing the switch from one element to another, we look at the coefficients. So our coefficient for sodium phosphate is 1. And our coefficient for sodium nitrate is 3. So now all we're going to do is we're going to plug these numbers into our calculator and we're going to multiply everything on the top and divide by everything on the bottom. So we're going to do 50 times 1 times 3. And then we're going to divide by everything on the bottom. Divided by 164 divided by 1. And then that gives us 0.914. We're going to round this to 3 sig figs just like we did for that. We're going to round this to 3 decimal places just like this one. So that means we're going to round right here at this 4. And so if we look at the 4, it's next to a 6, which means it's going to round up. And so we're going to end up with 0.1915 moles of sodium nitrate. And so you have two answers for sodium nitrate, and you have to decide, okay, which one of these is correct? Which one of these is the actual correct amount? And the correct amount is whichever one is less. So whenever you're doing limiting and excess, whenever you have two reactants and you do your two Stoke problems, you're picking the least, which is very important. You're always going to pick the least. So we look at these two numbers, and this one is smaller. Okay, this one is smaller, so this is our final answer. Okay, and now we can answer the next question. Which of the reactants is the limiting reagent or reactant? Reagent and reactant can be used interchangeably. So this is the same thing. You're going to look, you had your sodium phosphate and you had your ammonium nitrate. Whichever one gave you the least amount, that is your answer. That is going to be your answer. So we're going to look at that, and that means ammonium nitrate was our limiting reactant. Okay, guys. For the next problem, this is going to be our pre-APs only. So this is for my pre-AP babies only. So we're going to get started with the last question of this, and it says how many of the other reactant is left over after the reaction is complete. And so this is going to be another Stoke problem. So, but instead we're going to go from our limiting reactant to our excess reactant and figure out how much of the excess reactant is actually used in this reaction. So, first thing we're going to do is we started with, I'm going to go back up here, 30 grams of ammonium nitrate, and that was our limiting reactant. So that is going to be where we're starting. So we're going to start right here, draw our line, and we are going to be going, our starting point is going to be 30 grams of ammonium nitrate. Okay. And now, as I've already went over, we need to get to grams of sodium phosphate. So in order to do that, we need to do the switch. In order to do the switch, we need to be in moles. So we're going to convert this from grams of ammonium nitrate to moles of ammonium nitrate. And we already figured this out from the last question. The mass of ammonium nitrate is 80 grams for every 1 mole. So we have 80 grams is 1 mole of ammonium nitrate. Now we have moles of ammonium nitrate or ammonium. Oh, I put ammonium phosphate up here. It should be ammonium nitrate. Sorry. Ammonium nitrate. Now that we have moles of ammonium nitrate, we're going to take this unit down. And we have moles of ammonium nitrate, and we want to convert to moles of sodium phosphate, which is our other reactant. So we want to go to moles of sodium phosphate. And then in order to do that, whenever you're doing the switch, it's going to be mole to mole, and it's going to be the coefficients. So our coefficient for ammonium nitrate is 3. And then our coefficient for sodium phosphate is 1. Okay. Now we have our sodium phosphate. But if we look at our problem, we were given moles, we were given 50 grams of sodium phosphate. So we need to convert to grams of sodium phosphate if we're going to see how much extra we have, because we want to see how much is used. So then we can figure out how much extra we have. So we're going to go from, we're going to take this down, and we are going to go from moles of sodium phosphate to grams of sodium phosphate. Okay. And then just like before, we already have done this math, and 1 mole of sodium phosphate is 64 grams, is 164 grams. So we're going to have 164 grams equals 1 mole of ammonium phosphate. And so then we end up where we want, which is grams of ammonium phosphate. And we are going to do what we have been doing, which is multiply the tops and divide by the bottoms. And so in order to do that, we come here, we do 30.0 times 1 times 1 times 164 divided by 80 divided by 3 divided by 1. So, delete. That's a mess up. Divided by 3 divided by 1. Okay, so then you notice I multiply everything on the top and divide by everything on the bottom. Okay, and then I press enter, and we end up with 20.5 grams of sodium phosphate. And that is how much sodium phosphate was used. But this is asking how much is left over. So that means we have to know how much we started with. And we started with 50 grams, according to our problem up here. It says 50 grams of sodium phosphate. So we're going to take what we started with, 50 grams, and we're going to subtract the amount that was used, which is 20.5 grams. And so we're going to put that in our calculator. 50 minus 20.5 gives us 29.5 grams were left over. 20.5 grams of sodium phosphate were left over. Okay, guys, hope you have a great day.